Today, everybody, we get to start our trig odyssey, our trigonometry odyssey that's going to take us over the next 3 chapters. So this is the foundation. This chapter 5 has a lot to do with talking about triangles. So we're going to be doing a lot with triangles and looking at ratios in triangles. But today we're just going to focus on in 5.1 sort of laying that foundation with just discussing angle measurements. How do we deal with angles? Because we need angles to make up triangles. So when we're making our pictures, we're going to be doing a lot with angles. So that's what this section 5.1 is all about, dealing with angle measurements. How do we write them? Some just sort of standardizing, I guess. So we're all thinking of them in the same way. Because if I ask you to visualize a 30-degree angle, I think a lot of you have a picture in your mind of what that looks like, but there's a lot of different interpretations with where we would put it or what direction it's opening. So when we think about angle measurements, we need to put them all sort of in the same framework. So that brings us to our first idea today, which is called standard position. If an angle is going to be in what we call standard position, then its vertex of the angle has to be at the origin. So I'm going to kind of label my pieces here. The beginning of the angle always has to start on the positive x-axis. So that first ray that makes up the first part of the angle, we call that the initial ray, or the initial side, some people say, is going to be on the positive x-axis. Then you go ahead and measure your angle. So I'm going to measure in this direction just so we know which way I'm going. So I'm going to use the arrow to show the direction that my angle is measuring. Then when we get to the end, whenever it's the right size, that's called the terminal ray, or the terminal side. Now, what does it mean to terminate something? The Terminator. What did the Terminator do? He ended things, right? So terminal side means the end of it. So initial is where the angle starts, and the terminal is where it ends. So you have a beginning and an end. If everybody draws them this way, though, we are all starting in the same spot, ending in the same spot. Visually, it's much easier for people to be able to look at that. Now, what we're going to label that or call these, we're going to use a symbol, a Greek letter. It's called theta. So when you see this, that's the Greek letter theta, and it's sort of the international symbol for angle measurement. So you can use lots of other variables. Obviously, you don't have to use theta, but we'll use that a lot. You can use lots of different things, but that's sort of the conventional Greek letter of choice for that one. So that's called standard position. All right, now let's talk about how you measure angles and how they compare, like in the coordinate system, what kinds of numbers are we dealing with here? If we went all the way around the circle one time and end up back where we started, how many degrees would that be? Well, that would be 360, and that's considered to be a rotation. So 360 degrees is one complete rotation, or some people call that revolution, revolving around something. So one complete revolution or a rotation is 360 degrees. But you can do that differently if you're in the coordinate system. You can start at the positive x-axis and you can go counterclockwise, so in this direction for your angle measurement. And if you go counterclockwise, that's considered to be a positive rotation. So you're rotating in the positive direction. So going counterclockwise, we consider that to be positive. Well, it kind of makes sense. If we start labeling our quadrants in the upper right, we go around counterclockwise, right, to label those quadrants. So it makes sense, I think, that people think that's positive. What would negative be? Well, it's the same idea. We start in the same location, but instead of going counterclockwise, we're measuring in the opposite direction. We're going down first for our theta. That means we're going clockwise. That would be considered a negative rotation or a negative angle. So the sign of it is telling you which direction you're measuring. Are you going up counterclockwise or are you going down clockwise? So just understanding the difference between those, knowing what that's going to look like. So our first goal today is just, can we visualize and all draw the same picture? So I want you to be able to draw an angle in these locations. So they say in standard position, that means every single angle that we draw is going to start with the vertex at the origin and the initial ray on the positive x-axis. All right, now we want 320 degrees. So 320 degrees, let's get our benchmarks in here. We're starting at 0. Up here at the top would be 90. Over here would be 180. 270 down at the bottom, and then 360 if I go all the way around. So 320, think about where that's going to put you, will be between 270 and 360. So we're just kind of guesstimating on our picture here, but there's a few things I need you to have for sure. The arrow to show the direction you went around, and the arrow that's that terminal side. So that would represent 320 degrees. I like to label in there so people know what I drew. So 320 degrees, the terminal ray ends up in quadrant 4. It's a positive angle, so I went counterclockwise. Okay, well, negative. Let's talk about about a negative angle? You still start at the positive x-axis. Negative 110, if I'm going in the negative direction, down here then would be negative 90, negative 180, negative 270, and then all the way around would be negative 360. Just get your benchmarks in your mind. You don't have to write them every time, but just think about where that would be. So negative 110, that means I'm going to have to go a little bit past negative 90. So we're going to be down here in quadrant 3. So a negative angle means you're going to go the same distance, 110, but in the opposite direction. It's a negative angle. Okay, how about 990? What's going on with 990? What does that mean if you've gone 990 degrees? Well, you've gone around the circle multiple times. We have multiple revolutions. So let's think about how many times we went around. One revolution, one complete rotation is 360. Two complete rotations would be how much? Double that, so 720. We are going around at least 2 rotations. So let's subtract off 720, see what that leaves us with. Looks like 270 more. So this angle, 990, we go all the way around the circle once, all the way around the circle twice, and we go another 3/4 of the way around the circle, or 270 degrees, and we end up right on this negative y-axis. So 990 degrees is 2 complete revolutions, or rotations, and then another 3/4 of one, another 270. So we actually end up in the same location as where 270 is, and we're going to talk about that in just a little bit, these things that seem to end at the same spot. So you can have angles that go around multiple times before you get to your final location, your terminal side. So numbers bigger than 360, positive or negative, we're going around the circle more than once. All right, let's talk about that going around the circle here. When you're looking at these words, then I need you to understand what that means in terms of an angle measurement. So if I tell you you're going to rotate 9 times counterclockwise, what would that tell you? Well, a rotation, that's 360 degrees. We're going to do 9 of them. Counterclockwise means the angle is positive. We're going around in the positive direction. So I'd have 9 rotations of positive 360, just multiplied out, just little arithmetic. That would be the same as 3240. So 3,240 degrees. So 9 times around. So just think about visualizing 9 times around the circle in the positive direction. All right, well, what would this one be then? 3.75 rotations clockwise. Well, clockwise means a negative angle. 3.75 means you're going around completely 3 times. And then 0.75, 3/4 more. So kind of visualize that. Go around negative direction 3 complete times, and then 3/4 more. So 3.75 times negative 360. That would put you at negative 1350. Doing the arithmetic is not a big deal. That's just multiplying it out. But being able to visualize negative direction, so we're going in the negative direction 3 times, and then 3/4 more. So you'd end up here. So thinking about what that picture is, I think helps visualize that as well. So understand what the words are telling you in terms of those rotations. Okay, we're going to talk about 2 concepts now to finish up this part 1 that are really critical to our understanding as we move forward. So be really careful that you're understanding what's happening for these. I'm going to draw a picture here, and I'd like you to draw one as well. I'd like you to draw a 30-degree positive angle, so positive 30 degrees. So initial ray in the positive x-axis. We're going to measure 30 degrees in the counterclockwise direction. That's going to be my theta. Now, what I'd like you to do, and you might need to pause the video to do this, I want you to think of another way that you could draw an angle, name an angle, and that when you draw it, you end up landing in the exact same terminal spot. So another name, another direction, another idea to be able to get to that same ending spot. So pause the video for a second, see if you can come up with one. All right, so a couple common ones that people will come up with. One of them is 390. Thinking about this idea of rotation, if I do 390, that means I start here and I go all the way around the circle once, that would be 360. And I'd have to go 30 more, which would end me in the same location. I'd have the same terminal ray. So 390 would be one way to do that. In other words, starting at 30 degrees, doing a complete revolution from there. So starting at 30, going all the way around again. Well, could you do that again? Sure, if I went around the circle twice and then landed at 30. How about 3 times, 4 times, 5 times? How many of these are we going to be able to have? Lots, infinitely many. Now, I don't just have to do it in that direction though. Let's take a look at a negative possibility. What if I started here and instead of going around in the positive direction, what if I went in the negative direction? Could I also end up there? Well, that would be the same as negative 330, and some of you maybe came up with that one. So negative 330 is going to land you in the same location as well. And again, you could have gone around a couple times first before you landed. So there's infinite many of these. So what does this idea mean? Why are we talking about ending in the same location? These are called coterminal angles. Co meaning they share something. So they're sharing something. Terminal, what are they sharing? Their terminal side. So they share a terminal side. So these are angles in standard position. So they have to all be drawn the same way. So angles in standard position that have the same terminal side. That share the same terminal side. Another way to say that, and some people just kind of common sense, these angles end in the same place. They end in the same location. Now, how do we find them? How do you get those? Well, what you were doing when you were going around the circle there is you were adding revolutions or subtracting revolutions, rotations from the angle that you have. So you just add or subtract 360 from your angle measurement. So you're going to be going around, and there again, there are going to be infinitely many of these guys because you could do that as many times as you wanted to. So we can find these coterminal angles. So add or subtract 360, infinitely many coterminals with every single location that we have. All right, so let's talk about that a little bit. I want you to practice coterminal. So when we talk about coterminal angles, we want to be able to find what they are. So I need to just sort of visualize for you first what 65 degrees looks like initially. Quadrant 1, 65, that's my theta. How would you find an angle that is a positive one? So going in the same direction that 65 did, but ends in the same location. Well, I could go all the way around the circle once and then end there. In other words, I'm doing a complete revolution or rotation from that 65. That just means take 65 plus 360, and we would be looking at 425 degrees. So if I graph 425, it would end in the exact same location. All right, well, how could I get a negative angle doing the same thing? Well, instead of going around in that direction, what if I started here and it went around this way to get to that location? Well, that would be 65 minus 360, which would put me at negative 295. And those are just two examples. There's infinitely many of these that you could choose from, right? You could keep adding or subtracting in both directions. All right, let's talk about 410. This is kind of interesting, what happens with this guy. So 410 initially is more than one rotation or revolution around. We have to go all the way around once, and then how much further? Well, looks like about 50 degrees further, right, to get to that. So when you think about that picture, if you want to find an angle that's coterminal that's positive, well, you could add 360 if you wanted to. That would get you to 770. That's great. But could you also get a positive coterminal if you subtracted 360? Well, sure, because you're more than one complete revolution. It'd be 50 degrees. So there's lots of choices, but 50 might be a nice way to go. It's coterminal with 50. How would you find a negative angle then? Well, from 50, just subtract. We just got to keep going in that opposite direction. So if you keep subtracting 360, eventually, depending on how many revolutions you have, you're going to end up with an angle that is negative. So negative 310 would end up getting you to that same ending spot. So again, there's lots of them, but you might have to add or subtract more than one time to get to an angle that's positive or negative, depending on what you're trying to do. Okay, so coterminal. Infinitely many of them. So getting into that, how do you identify all angles that are coterminal then? If there's infinitely many and I asked you to identify how many, we'd be kind of stuck because there's no way you can list all of them if there's infinitely many. However, we can write an expression to describe that. So to find all the coterminals, you'd have to add and subtract every possible multiple of 360 that there is. Every single one. So there's a way we can write that. We say plus 360k, where k is an integer. Okay, what I mean by that is integers, remember, are numbers like 1, 2, 3, dot, 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 0, -1, -2, -3. So if you take all of those multiples of 360 and add it to 172, you will get all the possible values for those coterminals, because you're going to do 360 times 1 and 360 times 2 and 360 times 3 forever, and then 360 times -1, 360 times -2. Those would be all the subtract ones. So if we can agree that k is an integer, then we can write out this list and we don't have to think about each one of them individually. We can do it as an expression. So that's how we're going to be able to describe all possible. So thinking ahead to like solving equations, how would we say all of them? We'll be able to do it with that expression. Okay, last concept of the day, a really important thing to talk about as well. It's called a reference angle. When we boil everything down for what we're going to do moving forward, reference angles are going to be what we need to do almost every single time. What a reference angle is it's a distance. It's a distance that this particular angle, the terminal side, is from the x angle. So the reference angle is the distance from the terminal side to the x-axis. So the angle is formed with that terminal side and the x-axis. So it's a distance. How far is it? If you look at the picture right here, this is the reference angle they're talking about. So from the terminal ray to down to the x-axis, how far is it? How much further would you have to go? This idea really reminds me a lot of absolute value. When you talk about absolute value, what is it? Absolute value is the distance from 0 on a number line. So whether you go to the right or to the left, how far away am I? And remember, when you talk about absolute value, those distances are always what kinds of numbers? Well, they are always positive. So for us as well, because these are distances, these values, these angles are always positive, and they are acute. It's the acute angle, the acute distance, or the shorter distance to the x-axis. So think about reference angle kind of like distance from 0. It's just like absolute value, but our distance from 0, 0 meaning the x-axis. So we're figuring out how far are my angles, either above or below, wherever they are, how far away from the x-axis are they? Always positive, always acute. So we're talking about this angle right here, not this longer distance back to the x-axis, the shortest way to get there, the fastest route. So always positive, always acute, unless you're at 90 degrees. If your angle measurement is 90 or it's 270, how far are you away from the x-axis? Those would actually be 90 because you're 90 degrees away. But for all the other ones, it's the shorter distance back to the x-axis. All right, so let's talk about that. When we look at reference angle, then I think it's helpful to look at where the picture is originally. So I think it's helpful to draw the initial angle here, this 135. So it's in quadrant 2. The terminal side is in quadrant 2. What the reference angle is this distance right here, the distance from the terminal side of 135 to the x-axis. So that's the angle that you're trying to describe. That's the reference angle. All right, so how would you figure out what that reference angle is? Well, if you're in quadrant 2, I'm just going to just abbreviate here, reference angle. What you're trying to figure out is how much further do you have to go till you get to 180? Well, that would be just 180 minus 135, or 45 degrees. So my reference angle tells me how far 135 is away from 180. We're going to go back and kind of summarize this once we're done looking at these examples. So it's just how far are you from the x. So in this case, you're comparing to 180 because you're in quadrant 2. All right, let's take a look at negative 105. What would that mean? Well, negative means you're going in the clockwise direction. So remember, negative 90 is down here. So negative 105 would be about there. So the reference angle that you're looking for is this guy right here. How much further do you have to go to get to negative 180? So it's really the same as what we just did. I know we're still comparing to the same spot. How much further do you have to go to get to 180? Well, just subtract from 180 then. So we have 180 minus 105. We'd be at 75 degrees. So this reference angle means you're 75 degrees from the x, always comparing to the x-axis. So we're all doing the same thing. All right, let's try a couple more. 325, that's going to put you in quadrant 4. So 325 degrees. Now it doesn't make sense to compare back to 180 in this case, because what we're looking for is this angle right here. How far is it to get back to the x-axis from our terminal side? It means we should be comparing to 360 now. So how far is it from 325 to get to 360? What would that reference angle be? How would you figure that out? Well, just find the distance between them. Distance means difference. So that'll be 35 degrees. So it's 35 degrees more, and we would have gotten all the way around. All right, well, really similar question. Negative 325. Picture looks a lot the same, but you go the other direction. You end up in quadrant 1 instead. But same idea. I wanted to figure out how far I have to go to get to the x-axis. Well, that's just how far do I have to go to get to negative 360. It's the same deal. If you're going in the opposite direction, you're still going to do the same thing. To figure out my reference angle, I still have to figure out how much further until I get to 360. Still 35 degrees. So if you look at the last two, this is really important. You can have multiple angles that have the same reference angle. They're the same distance away from the x-axis, which is really important as we move forward to be able to know, oh, hey, those angles have something in common. This is a way that we can sort of standardize and talk about a bunch of angles at the same time, all the angles that have the same reference angle. All right, so speaking of that, let's try a couple more here. Let's talk about 484. Now for 484, that's bigger than one rotation around the circle, and I'm guessing when you say that angle, you may not know exactly where it is right off the top of your head, like you would if I said, what's 30 degrees, where is that? Everybody has a quick visual for that, but 484 is a little tricky. What I would do first is figure out what's coterminal with that. So go ahead and subtract 360 and see what that's the same as. What's another angle that ends in the same spot? Now, if I say 124 to you, I bet you know where it is. So when we graph 484, we go all the way around the circle once, and then we go 124 degrees more. For me, that's a lot easier way to be able to see that picture. So I'm thinking 124 when I do this angle then. So my reference angle is still the distance to the x-axis. It's still this guy right here. But now with 124, that's a lot easier to figure out. 484, that makes it a little bit trickier. Find a coterminal first. So we find that coterminal to make our life a little bit easier. All right, so how far from the x-axis are we? How far are we from 180? Well, our reference angle, we just find that difference. So 180 minus 124 would put us at 56 degrees. So another thing to keep in mind, 484 then has the same reference angle as 124 does. So all angles that are coterminal, that end in the same spot, have the same reference angle. They're the same distance from 0, which is a great way to kind of group them all together and talk about things that are the same about them. So we're going to be dealing with that a lot. Okay, last one of these we're going to do, and then we'll kind of go back and summarize this. So 221, that's in quadrant 3. So 221 degrees. When you're in quadrant 3, we hadn't done one of these yet, going in the positive direction anyway. We're looking to see what it would be to get back to the x-axis. So if we went to 221, we passed up 180. How far past did we go? So your reference angle would be 221 minus 180, so you'd be back at 41 degrees to get back to the x-axis. So even though we went past it, it's still positive, it's still acute. All right, so let's go back to that picture with all the different reference angles information here. What I'm going to have you do is go ahead and draw 4 little xy axes so we can sort of summarize what we just did. Now, we didn't do one of these other than maybe just talk briefly, but I don't think we really talked about one that was in quadrant 1. If your original angle is in quadrant 1, like say 30 degrees, and I asked you to graph 30 degrees, how far is 30 degrees from the x-axis? Well, it's 30 degrees. So when you have an angle that's in quadrant 1, so we're just going to kind of separate this by quadrants. If you have an angle that's in quadrant 1, the reference angle is equal to the angle. I'm using theta for the angle. It's exactly the same. However far you went, that's how far you are from the x-axis. So there's really not a lot of, I guess, calculating to do. Okay, what happens if you're in quadrant 2? All right, we did a couple of these. If you're in a quadrant 2, so I'll call that my theta, to be able to figure out the reference angle, the angle over here, we need to figure out how much further till we get to 180. So to figure out your reference angle, I'm going to abbreviate a little bit, we're going to have to take 180 minus the angle, right? We need to figure out how much more do we need to go? What is that difference between 180 and your angle? All right, how about quadrant 3? What happens down in quadrant 3? We just did one of those. That 221 was a great example for quadrant 3. How do we figure out the reference angle? We've got to figure out how much past 180 we went. So if our angle is theta, how would we figure out the reference angle? Well, think of our 221. We subtracted 180, so theta minus 180. How far would you have to go back to get to 180? All right, then our last one, quadrant 4. If you're in quadrant 4, if that's your angle measurement, How do you figure out how much further to get back to the x-axis, this reference angle? Well, now you're comparing to 360. How much further do I have to go to get to 360? So your reference angle would be 360 minus theta. Now, if it doesn't help you to like memorize these, don't. You can definitely just use common sense, but there are patterns that this follows because we know what's happening in each of those quadrants. All right, so make sure you know how to graph an angle in standard position. Make sure you know what positive and negative mean for angle measurements. Make sure that you understand coterminal, end in the same location, and reference angle, the distance to the x-axis. End of part 1. Tomorrow we'll do some graphing calculator.